Good morning, and today we are going to see the lecture number.
Multiplication of two signals. The Fourier series, if you apply to the multiplication of x of n and y of n. Okay, the statement I am writing the statement to the so two signals are considered x of n and y of n. Their Fourier series is x of k and y of k. X of n
Lecture number
Fourier
31.
series x of n is x of k.
Armature
Fourier series of x of n is x of k. And here the both the
windings.
signals have fundamental frequency or fundamental period is
Okay,
same. X of
introduction.
n and y of n. Both the signals are periodic signals with the same fundamental period.
Introduction. So we know that
So
in the
x of n
alternator,
and y of n
this
both
is the
are
alternator.
having same fundamental period.
We are giving
The
three-phase
fundamental
supply R, Y,
frequency
B.
is omega
So
naught.
you know the
Omega naught is
waveform
2
of
pi by n.
three-phase alternator
Right?
waveform.
So if Fourier series of x of n is x of k and Fourier series of
It
y
will be
of
like
n is y
this.
of k,
Okay.
then
So this alternator waveform,
multiplication
it's
of
having
x of
this
n
A,
and y
call
of
it
n,
as
then the Fourier series
R,
of multiplication
B,
of x
call
of
it
n and
as
y of n.
Y, and C, call
This
it
is
as
normal
B.
multiplication. I know you know how to
This is the
multiply
phase
the
shift
two
diagram.
signals, right? X of n and y of n are discrete time signals which are
R,
periodic having the same
Y,
fundamental period. So I default
B.
apply
The
Fourier
phase shift
series.
for
Fourier
each phase will
series
be
will have the
120
same fundamental period.
degree. So total
So
how
if
much?
you get
So
convolution
total
between
you will get
phase
360
frequency domain.
degree. Okay, that is nothing
So
but
you have
one
to
cycle.
remember the statement of
One
our
cycle, call
properties.
it as
Since these x of k and y of k are also periodic in DTM,
360
the time domain signal and frequency
degree.
domain signal both are
You see
periodic.
here,
So
the
the
R phase, it
convolution
starts from
between two
0.
periodic signals is
It will be
periodic
get
convolution.
entering at 180,
So
then it
x
will be
of k
reaching
convolution with y of
360.
k.
So this 180 call it as pi, and 360 degree call it
Right?
as
So this
2
I am naming
pi.
as
So the
some
combination of
variable
0 to
for
pi and pi
multiplication
to
of
2
two
pi, it is
signals,
one
which are named
cycle,
as z
360
of n.
degree. And in the same manner,
And
the y
the
phase is also
Fourier
be
series
starts at
of z
90
of n is z
and
of
it
k.
will be moving to 360.
The
So
Fourier
what is the phase
series
shift
of
between
z of
R
n is
to
z of
Y?
k.
You
So
see
it
here,
goes in
phase
this
shift
way.
between R to Y, it is 120 degree, and Y to B it is 120, and
This is
B
the
to R it
statement.
is
This is
120.
normal
This
multiplication.
concept you already studied in your basic electrical engineering circuits as well as DC machines. Whatever the electrical subjects you are studying, this is the basic sinusoidal equation. Now in our alternator, the EMF will be produced only in sinusoidal shape. Okay, the EMF is produced in sinusoidal shape.
So let's
So
suppose
the
this is
EMF
the
notation which we are
correlation
taking E.
property
Okay,
and proof.
E R for R phase, E R equal to, and this topmost line here you are seeing, right, this is EM.
So z of
EM stands for
z of k.
maximum
What is
EMF value. Okay, maximum.
Fourier series
So
definition?
EM
What is z of k? Z of k is
into,
equals to 1
this
by
is what type of waveform? It is
z
sinusoidal
of
waveform,
n
right?
equals to 1 by
Sine
summation
sine
of one cycle.
omega
Cycle means
t.
one cycle
Okay,
can take
so where omega is
one
the
cycle.
angular rotation,
Z
it is
of
2 pi
what is z of n?
f,
So in the
2 pi
place of
f.
z of n, I
Okay,
am
2 pi
substituting
f
this
into
directly.
t. So like
X
that
of n into
we
y
can
of n.
write it for,
Z of n is nothing but
this is for
left hand
ER.
side. Z of
Then
n, x
next
of n
EY.
multiplied with y of n
EY equal to EM
minus jk
sine
omega
omega t minus how much? How much angle for Y?
So this
Can
is the
anyone tell me
definition.
what is
So
the angle
here
of Y?
in the place of x of n,
For
I am
ER it
taking
starts at 0.
one
For
more
Y
time.
it
So
starts
x
at
of n is
what
equals
angle?
to,
Can anyone?
you know that
Nishal Dinesh?
we know x of n. What is x of n?
Sir,
X of n is
How much
equals
angle for Y?
120, sir.
120.
Minus 120.
Yeah,
summation
120 degree. Okay,
so here I
and
am
like
not
that
taking any
EB. EB equal to EM into sine omega t. How much it is? For EB it is 240 degree. Okay, 240 degree. So this ER stands for this ER stands for R phase, okay, and Y stands for EY stands for Y phase, and this EB stands for B phase. Okay, because here there is no yellow color, that's what I have used this glitter colors. Okay, so this is my instantaneous EMF produced. Because the EMF produced in alternator, it is sinusoidal shape. Okay, so EMF produced in alternator as sinusoidal, as a sinusoidal shape. Okay, okay. Now we are going to see some of the winding technologies in armature. Winding technologies, because armature is the rotating part. Okay. Winding technologies in alternator. The first winding technology will be conductor. The first winding technology, which is conductor.
So here one exponential term is there, one exponential term is there. So I am taking common.
It's conductor. So can anyone tell me what is conductor? Can anyone tell me what is a conductor? Conductor means, what is conductor? Can anyone?
Now,
please give the reply, otherwise I will just record the video and I will upload it. Okay, this is my extra class for you. Okay, please give the reply. What is conductor? Anyone, or otherwise I will call the name wise. Likita, Likita, Shushma. Shushma absent, right? Likita also absent. I will note.
Sir,
Tell me. Ma, please give.
which holds good for electricity, sir.
Okay. So conductor means it is the material. Okay, the basic item. The conductor, which is the material that permits electrons. That permits electrons to move. The electron is nothing but current. Okay, electrons is nothing but current to move freely. To move freely. Okay, so in the conductor, the resistance value, the R value should be low. Okay, if it is low, then only the current will move freely. As well as no heat is produced. Okay, no heat is produced. Okay, this is the basic. Now, if the resistance value is high, what happened to my current? current is moving, okay, anyway it will be move, the current is move, okay, but there will be a heat is produced, it is produced, okay. So to protect this heating effect, we need insulators, we need insulators. Insulators means it is one of the bad conductor, okay, and that bad conductor means you can't see the current is really move, there will be a blocking effect has been taken place in the insulator. The insulators are normally it will be a rubber, okay, porcelain materials,
Then what is the Fourier series? If x of n is
porcelain,
completely could be imaginary, what is the Fourier series? If x of n
rubber,
is real and even, Fourier series of that. If x of n is real and odd.
plastic,
So you know what is even and odd signal.
plastic,
So in the first model we already
paper,
discussed. So here different cases. One is x of n is real. Second one is purely
glass.
imaginary.
Can you please
Real
tell
and
me the
even,
example of
real and odd.
conductor?
So four cases we
Anyone?
already discussed in the
Example of conductor,
Okay.
which is very good
So I am
conductor.
writing the statement.
Example of good conductors.
X of n, the Fourier series
Copper.
Good. Copper. Okay. So copper is the good conductor material. Okay. Which will be used. Okay. For all the applications. And next one, silver.
Fourier series of
Because copper means which will be used for our domestic applications. In our house, there will be a domestic wire will be there, right? Okay, domestic wires. That is nothing but copper. But silver, which is also a good conductor, but it is expensive.
is real. First case I will consider x of n is real.
Okay, which is expensive.
X of n is real. So if I apply
What about this one? Gold. Gold, it is very excellent conductor, but it is very expensive.
star of k,
Very expensive. Can anyone tell me where this gold materials are using in our engineering concepts? In our house itself, there will be a conductor, gold material are using. Okay. Not ornaments. Don't say it is ornaments. Okay. Somewhere they are using this gold materials. Can anyone tell where they are using?
Sir, in the processor of computer, sir.
Good. It is a process in computer processors.
I hope you are following.
Okay, for getting better, best, good performance, better performance. Okay, computer processors.
Apply Fourier series to that.
Okay, and in iPhones also they are using this gold materials. Okay, that's what the iPhone cost is very high. Okay, the next one, another material, call it as aluminium.
Equals to minus
Aluminum.
times x of minus k.
Aluminum materials. And if it is not expensive, it is normally used for same domestic and some industrial applications, aluminum materials. And next one, iron. Can anyone tell me where this iron materials are using? This iron,
Real and even.
where this iron material are using, but anyway it will be used in domestic. Okay, in our house we are using it, but where it is used, which place it will be used? Iron materials. Anyone?
Then if I apply Fourier series to that,
These iron materials are used in electric heaters.
see x of n
Electric
is complex
heaters.
means x of k also complex values. So if x of n is real,
Okay,
and even,
electric heaters.
then
Okay,
imaginary
now by
law
using
x
this
of k is
concept,
zero.
okay, now by using this concept,
Law,
we are going to take a conductor.
x of k
Okay, how the conductor will be look like in the
is x of n
winding.
is real and
The
odd.
conductor means it will be look like it should be a circle, small circle shape, and it should be
Odd. So if you
in a
apply
proper
Fourier series,
length.
then
Okay,
real part of
it should
x
be
of
a
n is
proper
zero.
length,
Then
L.
this is the statement.
Okay, proper length,
The real part
L.
of x of k is zero.
Understood?
In example,
So this
you
type of
take
a small circle shape
So all the four
called it as
10 marks.
conductor.
Any out of four, any two or three, any one.
Okay,
Depends
so in
on
another
any
word we can say
marks per
it
four,
will be
three
a
marks, five marks also.
single wire.
So x of n is real then x bar of k is equals to x of minus
single
k.
copper
X
wire.
of n is purely imaginary.
Okay, single
Then
copper
x bar
wire,
of k
small
is
wire.
equals to minus
Are you
10
understand?
minus k.
Are you understand my
X of
point?
n is a real
This is a
element.
conductor.
Then imaginary
Okay,
quotient is
next
0.
one,
If x of n
the
is real
second
and odd,
point,
then real part of x of
which
k
is
is 0.
turn. T-U-R-N. A turn means a conductor is one slot, okay, when connected to the another slot. That is, this is the conductor. Okay, this is a conductor. One.
So statement also you should remember.
This is conductor.
You know it.
One. I am taking
I told all these
another
properties
conductor.
again comes in the continuous time Fourier series, discrete time Fourier transform,
2.
and continuous
Okay,
time Fourier
so there
transform
are
and J transform.
two conductors, and these conductors will be placed, because every conductor, okay, this is a conductor you see in our diagram. This is the conductor. Now this conductor we have to place in a small square box, a small square box. This is known as slot. This is known as slot. Okay, so this conductor should be placed in a slot. It should be placed in a slot. So this box, call it as slot 2, and this one call it as slot 1. Okay, so there are two slots are available. Okay, every slot there will be a conductor. Okay, there will be a conductor, and this conductors, it's a wire, right? Okay, so how we have to draw the shape of this conductor means a single, yeah, because this is one conductor. Okay, this is one conductor. It should be draw a triangle type. Okay, it should be draw like this. It should be in triangle position. Okay, three edges are there: top edge, left edge, and right edge. 1, 2, 3. Okay, this is the shape of this conductor. Okay, and this shape, it's called it as turn. Are you understand? This shape is called it as turn. So the combination of this wire connected in conductor 1 to conductor 2, we can have to say, call it as coil. Okay, so how many wires are connecting? Anyone tell me? It is a single wire or it will be 3 wires? There will be one wire. This line, call it as a single conductor. Okay, we have to say it will be a single turn coil. Single turn coil. Are you understand my point? Are you understand? We are taking a two conductors. In that I am taking a only one wire which is connected in between conductor 1 to conductor number 2. So we have to call it as a coil. So what type of coil which will be as a single turn coil? Okay, which will be a single turn coil. Okay, and how the multi-turn coils should be, we have to draw. Okay, multi-turn coil means,
here it is small letter, right? The left hand side, here it is capital letter. And this is
okay,
time domain.
two conductors. This conductor will be placed in a slot. Actually placed in a slot, and I am taking a multiple wires. Okay, multiple wires means there are how many? 5 wires which I am going to take up, because sorry.
X of n is we discussed that in first class. So x of n is equal to summation k is equal to
Okay, so like this we have to draw.
x of k
The shape is not coming properly.
e power minus j k omega naught e power minus j k omega naught.
Okay, so there are 4 wires are connecting, so we have to call it as, okay, the combination of these 4 wires. Okay, there are 4 wires are connecting. The combination of these 4 wires, call it as a coil, which we have to say it will be a multi-turn coil.
I am replacing 10 by minus 6. Both sides. I am replacing
Multi-turn
with
coil.
minus 6.
Any doubts? Any doubts? You know the difference, because in single turn there will be only one wire is connecting. Okay, that we have to say it will be a single turn coil. Multi-turn means there are multiple number of wires are connected. So this multiple wires, call it as a multi-turn coil. Okay, so this multi-turns, okay, the other name of this wires is known as turns. Okay, turns. The other name of the wires is known as turns. The turn is nothing but wires. Any doubts? Any doubts, students?
E power minus j k
Any doubts?
omega naught. Now I am
And the third one, and the
wherever
third term
2k and wherever
will be a
k
coil.
is 2k.
Okay, third term will be a coil. This coil is nothing but which consists of
N by
many turns. Okay, here you see, here there will be, here only one wire is connecting, we can say it will be a single turn coil. Okay, here you can see it will be 4 wires are connecting, we have to say multi-turn coil. This is the example. And the fourth one,
is there by k and wherever k
which
is
will be
there by n.
coil
So left hand
side.
side minus k.
Coil side means the coil, the part of the coil in each slot. Okay, we know that here you see the wires. Okay, here you see this edges, there are in one slot there are 4 wires are connecting, right? 4 wires are connecting, right? And this point, okay, the wires connected in the conductor inside the slot is known as coil
So I multiply
side.
both sides.
Okay, is known as coil side. Here also, which is connected inside. Okay, this is known as coil
With 1 by n.
side.
Now if you compare
Any
the
doubts?
definition, we
Till now
compare
you have any doubts, students?
x of n.
Have doubts?
Fourier series if you
Any
apply
doubts?
No, sir.
Okay,
the left hand
next,
side 1 by
fifth
n,
one,
x of minus k.
fifth point will be pole
So
pitch.
compare this one with the analysis equation. Compare this one with the
Pole pitch means
analysis equation. So we can write
it is the
Fourier series of capital X of n is 1 by n x of minus
center
and comparing this one with the analysis equation. Comparing with the
to
analysis equation. So the Fourier series of
center distance
1 by n x of minus
between
duality property.
two adjacent
Fourier continuous time Fourier series.
poles.
So any question
Two adjacent poles.
So with this
Okay,
CDFS is
normally
continuous time Fourier series.
for
So
360 degree, okay,
so next
this is 360 degree waveform. Okay, for 360 degree the pole value will be 2. Okay, pole value will be 2. Okay, and if it will be a 720 degree, 720 means this is the machine. Okay, for one revolution, that is for one rotation, it will be 360 degree. Okay, same machine will be rotating twice. Okay, which will be rotating twice. So what happened? 2 into 360, how much? You will get 720 degree. So this 720 degrees, 360 degrees, all are electrical. Okay, all are electrical. Why it is electrical means you are talking about generator, alternators. These alternators will convert mechanical into electrical energy. So whatever the electrical energy will be generating, that is nothing but electrical angles. Okay, 720-degree electrical. Okay, so here the number of poles will be 4. For 720 it is 4. Okay, like that. This is the relationship between number of poles and degrees. Okay, this degrees call it as electrical degrees. Electrical angle. Electrical angle. So therefore, pole pitch equal to, please take down, pole pitch equal to 180-degree electrical. 180-degree electrical. Okay, as well as in another name we have to called pole pitch equal to slots per pole, which is known as number of slots divided by pole, which is equal to n. Okay, which is equal to n.
Where T is the fundamental period. The capital T is the fundamental period, and omega naught. This is the representation for angular frequency. Omega naught in continuous.
Any doubts?
In discrete time, this is the omega naught.
Any doubts?
The fundamental frequency in discrete time, omega naught.
Next one.
Whereas for continuous time,
next one.
fundamental frequency is denoted with the letter.
Sixth one is
omega naught.
Slot.
So where x of t is equal to
angle. The slot angle notation is beta. Okay. What does mean by a slot angle? Slot angle means which is the phase difference. Phase difference contributed by one slot
where omega naught is the fundamental frequency and t is the fundamental
in degrees
omega naught is equal to 2 pi by
electrical. Okay, the phase difference contributed by one slot in degrees electrical. So beta equal to total 180 degree, because your waveform is sinusoidal waveform, like this is 360, this is 180. Okay, for every half cycle it is beta. Okay, beta equal to 180 degree divided by n.
If you apply Fourier series to the x of t with the fundamental
n call it as
omega naught, then
number of slots per
the
pole.
reverse also possible.
Okay, number of slots per
The
pole.
inverse Fourier series of x of t,
Any doubts?
then you get
If there will be a two slots,
so that's why
because we know there are two slots are connecting, right? You see the support diagram. These two slots. Okay, the one slot you can mark it as E1. Slot means conductor. Okay, another slot you can mark it as E2, means the angle between these two conductors will be beta.
so x of t
Beta
is
in
the
degrees.
representation,
Okay,
whereas x of k is
E1 and E2. Okay, E1 call it as a conductor, that is, or E1 style it as EMF produced in conductor 1.
modulus of x
E1
of
call it as
and
EMF
phase angle of
in
x of t is phase vector.
conductor 1. E2 call it as EMF
The magnitude of x of
in
t is modulus of x of k. The magnitude spectrum of x of t is modulus of
conductor 2. Okay, E1 stalled as EMF in conductor 1, E2 stalled as EMF in conductor 2. Okay, next title, types of armature winding. Because how many armature winding means it is a sinusoidal winding, right? R by B And in armature windings only, these are the parameters. Okay, now I am going to explain what are the types of armature winding. Okay, so there are three types are available in armature winding. The first type will be single layer and double layer winding. Single layer and double layer winding. And second one, full pitch
Here, two different signals, sin 2 pi t and cos 3 pi t.
and
Both are adding. The resultant is x of t.
short pitch
So the first signal fundamental frequency is different, right? The first signal sin
winding.
2 pi t. What is the fundamental frequency?
Third one,
Sine signal and
concentrated
cosine signal both are periodic. The sine signal and cosine signal
concentrated
both are periodic. So the fundamental frequency for the first signal, that is sine 2 pi t. So
and
omega naught comes equals to 2 pi.
distributed
Omega naught equals 2 pi. Whereas the fundamental frequency
winding.
for the second signal,
Okay,
that is
so there are three types of armature winding. One is single layer and double layer winding. Second one, full pitch and short pitch winding. Third one is concentrated and distributed winding. Now we will see one by one.
So
Okay,
what is the
first one,
fundamental frequency for the x of t?
single layer
Which is nothing but GCD of omega naught 1, omega naught 2. GCD is nothing but context of omega naught 1,
and
omega naught 2. So find out the GCD of
double layer
omega naught 1 and omega
winding.
naught 2. So GCD of 2 pi, 3 pi.
Single layer and double layer.
2 pi, 3 pi.
Single layer means
The fundamental frequency
single layer
for
means
x of t is pi. The fundamental frequency for x of t is pi. So
a conductor.
x of t in terms of exponential.
This is a conductor, okay, and which is placed in a
And then I will compare with the
slot. Okay, so this conductor is having only one coil side, that is inside there are multiple wires are there, but it should be one coil side. Okay, it should be one coil side. This is known as coil side.
Similarly, cos 2 pi t I will write in terms of
And this circle
e power
call it
j
as
plus e power minus j square
conductor.
cos. So e power
This box call it as slot.
e pi t
Okay, single layer winding means if a slot,
1 by
take down, single layer means if a slot
e pi t.
consists
So now compare this one
consists
with the
of
definition of Fourier
only
synthesis equation. So I am comparing with the
one coil
equation, which is second equation.
side.
Otherwise, I will write down
This winding
synthesis equation
is known as
and the first one is analysis equation.
single layer winding. Okay, this is known as single layer winding.
So now I compare
Double layer means
synthesis equation, then Fourier series quotient. I compare
double layer
synthesis equation, the Fourier
winding
series
means
quotient.
I am taking
So here
two
we compare here J
conductors.
omega naught. What is omega naught? Omega naught is pi.
This is the conductor 1 and this is the conductor 2.
What is the K value?
This both the conductors
JK omega naught is
will be connected
JK, sorry, J 2
in
So if you compare, K is 2.
one
So capital X of
slot. Okay,
X of what is the Fourier series
understood?
quotient?
This is conductor 1,
X of 2 is
this
1
is
by
conductor
2
2, and this both the conductors will be, actually this conductor is having
x of
a coil sides also inside the small circles because wires are there inside. Okay, example we can take the conductor call it as, we can take a coaxial cable. In our TVs there are wires are there, right? Coaxial cables that you can take. Okay, and this conductors which is having two conductors will be connected with
1 by 2
in only one slot.
and x of
These are
minus 4
wires.
1 by 2. So for all other
Understood or not? Okay, which will placed in only
equals to
one
plus or
slot.
minus 3
Okay,
is 1 by
one conductor in top, another conductor in
1 by 2
bottom.
minus 1 by
This
2.
type of structure
For all
is
other
known as
values x of t is 0.
double layer winding. Double layer
Writing
winding.
like this.
Definition:
X of a is 0. Fourier series quotient
there
x
are
of a is 0. But
two coils,
not equals not
sides
equals plus r minus 2
per
and plus r
slot.
minus 2.
One
Okay, for all other
conductor
values x of a
at
is 0.
bottom
Like a is 2, x of t is 1 by 2 j, a
and
is minus 2,
another
x is 1
one,
by 2 j, and x of t and x of minus 1 is
another
1 by 2.
at
Very question here.
top. So this
So here
structure
the signal is given mathematically. Sin 2 pi t
is known as
plus cos 3 pi t. The signal is given mathematically. So next problem, if the signal is given
double
graphically,
layer
how to find out the Fourier series? So next problem. For the signal x of t,
double layer
the signal
winding.
x of t shown below.
Okay, and second one, the second one is, second type will be
Find the
full pitch
Fourier series representation.
and short pitch
Find the Fourier series representation.
winding.
So the x of t
Full pitch and short pitch winding. What is full pitch? Full pitch winding is nothing but the coil is having a full pitch
it is a continuous
coil. Full pitch coil. Okay. So how the structure of full pitch?
So x of t is periodic signal. X of t
Wait one second.
is periodic signal. Okay. So here is 0, minus 1, minus 2, 1.
The structure will be,
So this is exponential decay rate, right? E power minus t.
this is a conductor
E power minus t, and the amplitude
which
is
will be
what?
placed in slot. Okay, this is slot 1.
Now, so what is the
Slot
fundamental
1.
here?
Okay, like that.
Signal graphically I given the signal. By looking into the signal, what is the fundamental period?
This is slot 2. So like that it keeps on going it, and till
Fundamental period.
it is slot
Anyone unmute your
number
give the answer. What is the fundamental period?
n plus 1. N plus 1 means 10, 11, 12, etc. N numbers it will be connected. Okay,
This is the
and this slot
this is one cycle.
I already told
Again
the shape of the slot
right? Yeah, the fundamental period is 1.
should be
The fundamental
a
period is
triangle
same
type,
cycle
right?
is repeated. If I start the signal at 0, then again the same cycle is repeated at
Okay,
100.
which will be the slot 1 is connected to the last slot. Okay, so like that the every slot now, for example, this is slot number 1, this is slot number 10 means will be connected only to 1 to 10, will be connected 1 to 10. So slot number 2 will be connected to 9, slot number 3 connected to 8, slot number 4 connected to 7. So like that, every slot is connected to the respective slot. That is, the starting of a slot 1 will be connected to the end number of the slot. Okay, last number of your slot. That is known as full pitch coil. The angle between this every slot number 1 to slot number 10, the angle will be 180 degree electrical. 180 degree electrical. 180 degree electrical. Are you understand? Are you understand or not? Okay. And short pitch winding. Next one we'll call it as short pitch winding. Sorry. Short pitch winding is nothing but a coil is slightly less than pole pitch. Okay, coil span is slightly less than pole pitch. So pole pitch means how much angle? It is 180 degree, right? That is less than 180 degree electrical. Less than 180 degree electrical. So this is known as, this is called short pitch winding. Short pitch winding. The another name of short pitch winding is known as fractional. Is known as fractional pitch winding. Fractional pitch winding. Okay. So how the structure of this short pitch winding? Conductor, slot. Okay, this is slot number 1. Understand? Now, this is the conductor. This is slot number 9. Okay. Normally, the conductor 1 to 10, the angle is 180 degree. Okay, but if you measure 1 to 9, the angle is less than 180 degree. Okay, less than 180 degree. Okay, this symbol called as less than 180 degree. Which is connected like this. Understand? Okay. Usually, this slot number 1, it should be connected only in where it is connecting. It should be connected only in the slot number 10. This is slot number 10. Okay. If it is connected, slot number 1 is connected to slot number 10 means that is full pitch. Okay, but here it is connected to 1 to 9, right? 1 to 9 means it is short pitch winding. Short pitch. Why we are calling this a short pitch means the angle will be less than 180 degree. The angle is less than 180 degree. Or understand the difference between the full pitch and short pitch? Any doubts? Any doubts? And what is the advantage of this short pitch winding means we can eliminate the high frequency harmonics. High frequency harmonics means there will be a high frequency distortions are available in our conductors sometime. Okay, high frequency harmonics we can eliminate, as well as we can eliminate the losses. So what type of losses we are eliminating means it will be a eddy current and hysteresis losses. Eddy current and hysteresis losses. And because of these losses will be reduced, we can improve the efficiency. Efficiency will be increasing. Okay. To improve the efficiency only we are going for this short pitch winding arrangement. Okay. Any doubt? These are advantages. Advantages. Okay. And third one, call it as concentrated and distributed winding. Concentrated and distributed. The concentrated winding, it's nothing but the all conductors or coils belonging to a phase are placed in one slot under every pole. One slot under every pole. Distributed winding is nothing but the conductors per phase are distributed among 3 slots per phase for every pole. That is nothing but distributed. Okay. So today class I explained what is mean by a armature winding, how to return the armature EMF produced in the armature winding equations. There are ER, EY and EB, and what are the 6 types of technologies, that is terminologies are used in this armature winding, and classifications are in armature winding. There are 3 classifications are available. One is single layer and double layer winding. Second one is full pitch and short pitch winding. Third one is concentrated and distributed winding. Okay. And next class I am going to explain the armature reaction. Okay, armature reaction and what is armature reaction and what are the types of armature reaction based upon the angle. That I am going to explain by next class.